radiator. We could be asked to find the marginal revenue. The marginal revenue is just going to be the derivative of the revenue, which, if we go back to the revenue function, is going to be 3x squared minus 6x plus 12. And it's going to have the same units as the marginal cost, dollars per radiator. Okay. You also might be asked to find what are these values at a particular number of radiators. So let's say that x equals 10 radiators. Well, obviously it's just a matter of plugging in 10 into those two functions. So c prime of 10 would be 3 times 10 squared minus 12 times 10 plus 15, which all simplifies out to 195. Again, if I use the units, that's going to be dollars per radiator. But dollars per radiator. Okay, so that's the marginal cost. That's how fast the price is changing when we build 10 radiators. R prime of 10, the marginal revenue, plug 10 in for x as well. And for this one, we get the answer of 252. So it's $252 per radiator. Probably the most important concept is what's happening to the profit at 10. And notice that these answers are both positive, okay, which means that the cost is increasing by that much for each radiator we make, but the revenue is also increasing by this much per radiator. Okay, so the fact that those are both positive means that the revenue and costs are both increasing. If they're negative, it would mean decreasing. So profit at 10, we can go back and find the derivative of profit, which here's our profit function. So the derivative of profit, go back to here, p prime of x, it's going to be 6x minus 3. And if we plug a 10 into that, it's going to be 60 minus 3, which is 57. So we get $57 per radiator. Okay. And notice that that happens to be the difference of these two amounts, which makes sense. Because if our money coming in is increasing $250 for each radiator we make, but our costs are only increasing by $195, the difference between those two values is the marginal value of profit. Okay? So, and that kind of goes back to the fact that profit came from the difference of the two functions anyway, so that should make sense, that relationship. Now going back to my original point, if we wanted to maximize profit, I want to find out where does the profit equal to 0. Okay, so my profit function was 6x minus 3. Add 3 over and divide by 6. I don't know if that makes any sense in this particular context. Making half a radiator isn't necessarily in the domain of the issue. Can't believe that gives us the maximum profit. And anyway, I just kind of made up that last part of the problem, so it might not actually make sense in terms of the context. But anyway, I guess the point is that's what marginal cost and marginal revenue mean. It's just derivative. So you guys have some other problems in the homework to deal with those. Hopefully they'll make more sense than the one I just made up. Okay, so there are some places where we use derivatives in real life, and hopefully that makes some sense to you and gives you some motivation to actually learn more about derivatives. And next class, we're actually going to have a quiz to see how well you're doing. It will cover everything from the definition of derivative, using the limit definition. There'll be one problem on that, and then there'll be a problem on using the product rule, a problem on using the quotient rule, and probably a problem from this lesson probably a simpler one, maybe like a velocity acceleration type of problem. So just a 4-problem quiz, just to see how things are going so far. And the next class's lesson is going to be on derivatives of trig functions, which will be a lot shorter than today's lesson, so you'll have plenty of time to work on the quiz too. Okay, hopefully this makes sense to you, and have a great day. Talk to you later. Bye.